Welcome back, guys. I hope all of you will be fine. So this is question 5.16 of chapter 5, and today the statement of the question is: suppose that airplane engines operate independently and fail with the probability equal to 0.4. Okay, assuming that a plane makes a safe flight if at least one half of its engines run, determine whether a 4-engine plane or a 2-engine plane has the higher probability for a successful flight. Okay, so here we have, you can see that the two scenarios in which either we will have 4-engine plane or 2-engine plane. Okay, and we will also try to divide this question into two parts, but before it, first of all, let us see that what is the probability of the engine failure or success. So the failure probability here is 0.4. So the probability of failure is basically here, and this is P of F. P of F is what? This is 0.4. So on the basis of it, we can also find the probability of success as well, and that would be what? That would be 1 minus the probability of failure, and it would be 1 minus 0.4, which is what? 0.6. Okay, so this is what? 0.6. Let me take it and move it from here to the other side. Okay, let me place it here. Okay, so now here, in order to solve it, what do we have to do? We have to keep it in two cases. Okay, we will have case 1 and we will have here case 2, and in those two cases we have to see what is the probability of success in these two cases. Okay, so in case 1 we have the number of engines equal to 4, and in case 2 we have the number of engines equal to 2. Here we can see that these are the two cases, 4 engine and 2 engines, and in each of these cases we have to see that what is the probability that the number of engines operate successfully are half or greater than it. So therefore here the value of k is half of it, that is 2, and here the number of engines half are basically 1. Okay, what do we have to find here? Here we have to find here the probability that the k is greater or equal to 2, and here we have to find that the probability that k is greater or equal to 1. Okay, so I hope it is now clear. Now let us proceed to case 1, and here in order to find it out, we can very clearly see that this is also equal to 1 minus the probability that k is less than 2. Okay, also let me do it like this one, that 1 minus probability of k is less than 2 would be what? It would be the probability that k is equal to 0 plus the probability that k is equal to 1. Okay, and this is basically the case of the binomial probability, because again we have two cases, failure and success, and this success is basically the true case, which is P, while this failure is what? This is false, which lies in the Q, because here we have to find the successful flight. Okay, so for the successful flight we have, this is the success rate, and we have to use it here. Okay, so let me use it here, the binomial probability law, and here what would happen, and choose k multiplied by the probability of success and q then. So here the number of n's here are basically 4, so n choose k and then p and then q, pk, qn minus k. Okay, and also here for k equal to 1 we will do the same, and k probability k q of n minus k. Okay, this is here. Let me move down somehow. Okay, and here in order to do so, let me put values here. The n here for the first case is 4, choose 0. Okay, the probability of success is 0.6. Okay, 0.60, and this is q, this is 0.4, and minus k is 4. Okay, similarly here 4, choose 1, the probability of k, this is 0.6 raised to power 1 and 0.4 cube. Okay, so let me solve it again. 1 minus 4, choose 0 will be 1, 0.6, this will also be 1, because anything raised to power 0 is 1. So here we will have 0.4 raised to power 4 plus 4 choose 1, this is 4 multiplied by 0.6 plus 0.4 cube. Okay. So in solving it, what will I get? It would be 1 minus 0.1792, okay, which will ultimately give me 0.8208. So this is the solution for the case 1 where the number of engines are 2 and the success of getting operational engines greater or equal to 2. Okay, this is for the case 1. Let me proceed to case 2 and let me separate them out. Okay, this one. So this is case 2, and here in order to find out this one, I can very clearly see that this is 1 minus probability that k is less than 1. So it would be 1 minus probability k is less than 1 is k equal to 0. Okay, using the binomial probability law again. So here 1 minus, now n is 2, choose 0. Okay, and the probability of success will remain the same, which is 0.6, and k, and also 0.4, and minus k, which is square. Okay, so 1 minus 2 choose 0 is what? This is 1 minus this would also be 1, and here 0.4 square. Okay, so it will be 1 minus 0.16, or the answer of it would be 0.84. Okay, so the solution of it is 0.84. So we can very clearly see that the probability of the success here is higher for the number of engines where the number of engines are equal to 2, which is very astonishing. And we can see that by increasing the number of engines, if the success rate is the same, which is 0.6, we can see that the higher successful flight will be made if the number of engines will be equal to 2, as we can see here, because here the success rate is 0.6. okay, and the other condition is that if half or more than half of the engines are in operational mode. Okay, so that's it for today, in which we have seen the performance of the binomial probability law in decision making for the airplane engines operation. If you have any question, you can ask me in the comment box. See you soon.